In this video, we'll be reading some variables off of a Samsung control valve to confirm calculations in ISA-75 for valve sizing. So right here is our Samsung control valve. You can see right now I have it fully open. I'm currently sourcing 20 milliamps to the valve, and we have about 13.3 kilograms per minute flowing through the valve. And the differential pressure right now across the valve is, you can see both these are reading in kPa. Over here we have, right over here we have about 104 kPa, around 100 to 104. And over here we have about 64, 63 kPa. So the difference being 38 kPa. So dP of 38 kPa across the valve. These two pressure crystal gauges here, you can see these are the two sensing lines for them. They are connected right here on either side of the control valve. So this would be the upstream. The pump, which is down over here, is feeding water through to our control valve. And so here we're measuring upstream and downstream pressure. And then it flows down along here and over through our Coriolis mass flow meter, where we're getting our 13.4 kilograms per minute, and then back down to our tank over here. The other variable that we want to grab off the valve, we'll just maybe zoom in here and get, we've got some part numbers and valve size here listed, and the flow direction. If we just move around to the back side here, this is where our valve CV, valve coefficient right there, a CV2, you can see. That's the coefficient, flow coefficient for this valve. So we'll use these variables to verify the ISA-75 valve sizing calculations. We'll also maybe we'll close the valve a little bit just to show how those values change. So we'll go to 3/4 open now. Flow rate dropped to about 10. And our differential pressure here has increased quite a bit. We went from 100, we're up to 115 roughly, and about 34 kPa. This here's our downstream. We'll drop that one more time to 50%, or 12 milliamps. And you can see the pressure values changed even more. About 130 and 130 and about 4.4, and at a flow rate of about 5. We'll drop it down to 25%. Flow rate's down around closer to 2, 1.9. And our differential pressure, we've got a negative value over here, and this is probably because the valve is almost closed. And we're draining back to the tank, so it's probably causing a suction effect here, giving us our negative value. So this last value here probably won't work for us. But you can see here we've got one of the highest differential pressures. The first three would probably work a lot better. So we'll use the first three, the 100%, the 75, and the 50% for verifying our ISA 75 calculations.